We're going to talk about the principle of inclusion and exclusion, and we're focusing on just two sets of information. So the number of students in A, and this union kind of here stands for the word or B, okay? And the one that's the upside down or the N is the word and. Okay, so one way you could kind of remember it is the N in and also occurs in the word and it looks like an N. Okay, to tell the difference between the upside down U and the N. And what it's saying is the number of players in A or B. Okay, so playing for, or not sorry players, but the number of items in set A or set B. And what that's equal to is the number of items in set A plus the number of items in set B, subtract the items that are in both, so in and A or B. And that is so we don't double count things. In a Venn diagram, this is the concept of A and B. You'd have so many in A, so we'll say you'd have so many red in here, so many blue in here, and then there's a small amount that occur in both of the sets, okay? And if we're trying to figure out just A or B, we would add these values together and subtract whatever's in there because we don't want to double count values. So let's read our question and we'll try to set it up, and I'll try to show you the idea of double counting things. So Moed High School, I missed that part there, but Moed has 22 players on their school baseball team and 18 players on their basketball team. How many could show up to a party for both teams if 7 players play on both teams? Okay, so let's try to figure this out using our formula here. Okay, so our formula states we want to figure out how many players would show up for A or B. And the reason A or B is because if we were to just simply add these two together, okay, we'll say, well, we have baseball team. We'll call that set A. So the number in A. And there's 22 players on that team. And set B is the basketball team. And we'll call that set B, and there's 18 of them. Well, if we were to simply just to add these values together, we end up at 40 players, but we know 7 guys play on both teams, so then we run into an issue that we're double counting guys. So there's somebody who definitely plays on both this team, and he's not going to show up as 2 separate people. It's still one person, okay? So the concept here is we want to count A or B. We have to figure out how many in both. So both will be our set of A and B. And they said there are 7 players on that. So in terms of our formula of figuring how many players on set A total or B, when we take our values, we have our 22, and we're going to add our 18, and we're going to subtract our 7. Okay, and that's exactly what we've done up here. Set A being our basketball or baseball team, set B being our basketball team. So we add those values together and then we subtract guys who are on both. So when it comes to that, we've already done some of the math. Like we said that we get 40, we add those two together. So we have 40 subtract 7, which means there would be 33 players who would show up to a party for both teams because 7 of the guys play on 2 of the teams. So we don't count them in this instance. Farther, okay, and we'll kind of help build a Venn diagram to help us out here. But let's say we want to know exactly how many guys only play on the baseball team and how many guys or girls only play on the basketball team. What we do have is the number who play on both, okay, and we know there are 7 of them, okay. We know the total number, so that would be, I guess I should have colored it, the total number here, so total, let's just keep the colors the same, on the basketball team is 18, right? So total basketball is 18, okay, and the total on baseball is 22. Well, we want to figure out how many just play baseball, and that's what this part's going to represent. This would be our set A, and over here would be our set B. Well, in order to figure that out, we have to take the total amount of players. So we figured out our total amount of players. We know there's a total of 18 on the basketball team and 7 play on both teams. So in order to figure out how many just play on the basketball team, it's just strict subtraction, right? We would take out our 18 and we would subtract our 7 players. And that's going to tell you how many just play on the basketball team. And that means there are 11 guys just on our basketball team. Okay. And the same concept over here. We have 22 total players on the baseball team. Well, we take our 22 and we're going to subtract the 7 who play on both. How many players only play on the baseball team? And that leaves us at the value of 15. Okay. Way you could have attempted this question. Once you have this tells you exactly how many players there are total. If we take a look, the total number of players is essentially these values added together, because we deduced how many just play basketball, how many just play baseball, and how many play both. Okay, so the addition of these will actually help us solve this question. Now, normally a lot of times is you would write this as this would be our 18 and this would be our 22. I just wanted to show the idea that if we were to talk about just only, okay? And the reason being is because a lot of times they'll use Venn diagrams to represent our unions, and when you do that, if you were to plug these values in for that first formula we talked about, this one, A or B, if you were to plug these values in 15, 11, and 7, well, that would be 15 plus 11 minus 7, which would give us, what is that, 26 minus 7, 19, which is not the right answer. That's actually not the right answer, okay? This really just gives us the information of who played only a specific sport. When they draw these types of Venn diagrams for you, they'll give you the total number, okay? And that's where we kind of repeat our process, where we do our 18 plus our 22, or 22 plus our 18 minus our 7, which gives us 33. And if you were to add up people who only played A, only played B, and who played both, that ends up being 33. So these three values here together actually add up to our 33.